Hello everyone. So we will be starting the session at 8:30. So in the meantime, do introduce yourself, do let us know about your background. Which clouds do you work on? Do you already work on Kubernetes, or is it something which you are planning to pick up? Do introduce yourself, right? Do let us know about your background. We'll start at 8:30 in approximately 15 minutes. So let us know about your background in the meantime. Hi, good evening. So let us know about which clouds do you work on, Azure, AWS, GCP, or any other cloud, and what's your background? Any specific expectation from us? Please do introduce yourself in the chat. Is Kubernetes something new which you are going for, or is it something which or is it something which you already work on? Do let us know about that. And I can see we yeah. So hi Vishwas, hi Priyant, hello everyone. Okay, so we are live on LinkedIn as well, and we are live on YouTube and Facebook. So if you face any issue when you are live, if you are watching it live on LinkedIn, we have seen in our previous webinar that the stream quality sometimes drops automatically. So if anything like that happens, please move to YouTube. YouTube stream quality doesn't drop like that. And if you're on YouTube, that's the best platform for the, you can say, the stream for getting a good quality stream as such. So Mamta is the speaker for the day, and we will start at 8:30 in around 10 minutes. Okay, so a lot of you have experience in Azure, AWS. Some of you are interested in Azure Arc. We have upcoming sessions also on Kubernetes. We are having another webinar on Kubeflow, which is coming up. Kubeflow is the ML toolkit for Kubernetes. Join us for that one. And we are also doing another webinar on MLOps for Kubernetes. MLOps for AKS, basically Azure Kubernetes Services, right? So you can go to our company's website, or you can go to our company's actually LinkedIn page. That's one place where you will find all the links and all the upcoming events. So uh, I will just give the company page in the chat window. If you are already following us there, that's great. If not, please follow us on the company page. And we have lots and lots of upcoming webinars planned for you. So let me give you the correct link. I think I have not giving the correct one. Okay, so we have many upcoming webinars on Kubernetes. So those who are interested, please find that. and we will start in next 9 minutes. In the meantime, please do introduce yourself, to let us know about your background. I will paste the YouTube link again in the chat. So there is, if you face any problem with the stream quality on LinkedIn or Facebook, then please switch to YouTube. I'll just paste the link again. The YouTube stream link is there in the chat now. So switch to YouTube in case you face any drop in the stream on LinkedIn. It has happened before, so just FYI. Please do introduce yourself. Do let us know about your background. Which clouds do you work on? Any specs, any special expectation from us? I hope you have the agenda for the day. I'm putting that in the chat window. So it's in the chat now. Please have a look at that. So we encourage that you ask questions. So if anything is not clear, if you want more information about any point, so Mamta will be able to answer your questions on the way also. And she will also take some logical breaks in middle and at the end also to answer the questions. So please put your questions in the chat during the session. Okay, so the YouTube link is going in the chat again. I have just pasted that. So use it. We will start in next 5 minutes. Please do introduce yourself in the meantime. Do let us know about your background. What do you work on? Do you already work on Kubernetes, or is this something new which you are planning to pick up? To tell us about your background. So we will start in next 3 minutes. Please use this time to introduce yourself. Do let us know about your background. The YouTube link is now in the chat. I have pasted that in LinkedIn's chat as well, directly over there. And I hope it is visible now. So if the stream quality on LinkedIn falls down, please move to YouTube, right? That has happened with us before. So just do that. So we will go live in just 2 minutes. Okay, so we'll go live in next 1 minute. Do introduce yourself. Do let us know about your background. And if you have any question, feel free to ask that. Put your questions in the chat, right? Hey, hi, Mamta.
Hi, Shubham. How are you?
I'm doing well. How about you?
Yeah, doing good.
So let's get started in next 1 minute, right? We are on
Yeah,
time.
sure.
Okay, I'm just muting myself. We can start in next 1 minute.
Sure. Thanks. Hey, guys. Good to see so many people introducing themselves. A lot of people are working in a lot of other various clouds where people are trying out AKS. It's good to see that Kubernetes is catching a lot of traction in the market. We would be starting in some time, just a minute, and we would be starting. Shivam has already posted the agenda on the chat. So we would be starting with Azure Arc, and then we would be looking how to register various clusters with Azure Arc. Before to that, let's introduce ourselves to the entire community who has been present over here. So to start with, I'd love to introduce my company first. We are called as Tech Scalable. We provide services across training and consulting, and we focus on various domains like cloud, DevOps, machine learning, data science, artificial intelligence. And we love to migrate teams or projects to various clouds. Let it be Azure, AWS, Google. We work on all the three clouds, and we do train in all the three clouds. So this was introduction about Tech Scalable, introducing myself. Today I would be the speaker on this topic of Azure Arc. I have around 17 plus years of experience. I have been working in cloud for last 9 years, working on various different clouds, AWS, Azure, Google. I started my journey with private cloud. I was working in telecom sector. So I started my journey from there as a layer 2, layer 3 protocol developer, and then moved on to the first cloud element in telecom called as wireless cloud element. And from there moved on to public cloud because didn't see that much of traction with respect to private cloud in Indian market. So this is a brief introduction about myself. Now looking at the agenda, we would be looking into what exactly Azure Arc means. Azure Arc supports various other services. Kubernetes is one of them. It's just not that Kubernetes is the only service which is being handled by Azure Arc. So we would try and understand what all services Azure Arc helps us manage. We would be connecting various clusters. So on the fly, in this next 2 hours, we would be spinning up a AKS cluster, which would be Azure Kubernetes cluster. I would be spinning up a Google Kubernetes engine, a Kubernetes cluster, managed Kubernetes cluster solution by Google, and also a EKS, which is AWS Kubernetes service. We would be registering all these 3 clusters with Azure Arc, and we will see how it works. So obviously, when Azure Arc has to manage these clusters, various clusters working in varied different environments of the public clouds, or even we can register from the on-premises clusters of ours. How do we manage? There are some agents. We will look at the list of the agents which help us attain this. Then we have very beautiful services called as Container Insights, which is part of Azure Monitor. We will see how do we utilize Azure Monitor to manage or to monitor these clusters which we have registered with Azure Arc. So that's our agenda for today. Now, Azure Arc, as I said, doesn't only manage our Kubernetes clusters, it has very different like spectrum of managing various different services as well. You can see here, they are all listed. I can have a physical server or a virtual machine running Windows operating system or Linux operating system. I can manage all of them all together from Azure Arc. Those servers can run in Azure, they can run in on-prem, they can run in AWS, they can run in your, say, any of the clouds, IBM cloud, whichever cloud you name, it would be supporting that. Now, servers running on different cloud providers, infra or on-prem can be registered with Azure Arc. Same way, Kubernetes is also an infrastructure as a service offering or a managed services which we offer. Either of them. I have a Kubernetes cluster created on-prem. I create a fully unmanaged Kubernetes cluster and I manage it myself. I have the masters, the workers, everything. I can register that cluster in Azure Arc. Or I have EKS, AKS, GKE type of solution, which are managed solutions from various cloud providers. I can even register them with Azure Arc and control the Kubernetes cluster from a single place. The beauty of it is if I want to apply something, I can do it on the fly and it would reflect in all of the clusters. I can even go to that level of automation using GitOps and on. We would see that as well. We also manage data services using Azure Arc, like SQL or PostgreSQL services. That also is managed by Azure Arc. And few things are in preview at present, but yes, anything on-premises or any multi-cloud, even the edge locations, like I have K3S clusters, that also can be managed by Azure Arc. So we can go ahead and manage any sort of infra which we are having with our Azure Arc. And that should be a central location for us. I have spin up, rather I would say I've not spinned up, I have my laptop in which I have installed all of them. Like I have installed the CLI of my Azure, I have installed the CLI of AWS, I have installed the CLI of my Google, and we will see how exactly we work with it. So just to give you a brief understanding about what we would be doing. So this is my Azure account, I would say. Inside this, I will create a resource group. So in Azure, all the resources are managed under resource group. In this, I will have my Azure Arc. Let me write it as AZ Arc. I'll have the Azure Arc. And in this, I want to register the clusters. So we would be registering 3 clusters, 1, 2, and 3. One would be our 𝐀𝐠𝐞𝐧𝐝𝐚 cluster. One would be 𝐀𝐠. The steps are pretty similar. There's nothing different. But yeah, it's a bit complicated. The command's a bit lengthier. So we got to understand them and do it. That's the reason I would be showing demo across all the 3 clouds and trying to show registering all the 3 clusters. Even though it is 𝐀𝐠 cluster, the registration process remains the same. How you register a 𝐀𝐠 or a GKE remains the same. Even if you have a on-prem, you can do that. I'm not doing this piece. I tried installing, but today, due to lack of time, I didn't do that. I was planning to do this today, execute this and keep it, but somehow this didn't happen. So we would not be doing the on-prem part, but yes, you can even try out that. The steps all remains the same. There's nothing different. Now I have my laptop here. Let me draw my laptop here. This is my laptop. In this laptop, what all things I've configured, I'll tell you. I have configured 𝐀𝐠𝐞𝐽, which is command line interface to talk to my Google Cloud. I have installed my AWS CLI, which will help me interact with my AWS cloud. And then I have installed my Azure CLI, which helps me in talking to my Azure interface, right? This would help me interact with my Azure cloud. So these things I have installed already, and I have kubectl in my laptop, a Kubernetes command line interface. This is to interact with any Kubernetes cluster. This is a Kubernetes command line interface. And I have installed Helm as well. So why we are using Helm? When we use this, I'm just putting a star mark over here. When we use it, I'll just brief you about what exactly Helm is doing at the background. You would not realize that Helm is used, but yes, certainly Helm is playing a role for us to deploy the agents, which would be running in each of the clouds. So this is the configuration of my laptop. Instead of doing on a laptop, you can pick up a VM on a cloud and you can configure all of these so that you can interact with your every cloud provider's interface and register those things with Azure Arc. Now, this is one setup. So this would be step number 1. We would be doing step number 2 over here. Step 1 is obviously up and ready. I have all these softwares already present in my system. Step number 2 is something we would be doing right now. So we would be spinning up 𝐀𝐠 cluster, 𝐀𝐠 cluster, and GKE. And then we will see how do we register that with Azure Arc. So let's look into the services section of Azure Arc and try and understand what exactly we mean by registering and all that stuff. So I don't have too many slides to depict the things. I'll just increase the font size. Someone is mentioning the font size is pretty small. I'm not sure about it. Okay. Fine. So if you go on the top, or you can go from here as well, look at the resources on the left-hand side, different ways people try to browse through the portal. You can type Arc and you would find Azure Arc on the top. So Azure Arc is the name of the service. Here you can see it has various other parameters like infrastructure has servers, Kubernetes clusters, SQL servers, and Azure Stack. Same way you have different services of PostgreSQL, SQL, App Service, Logic App. These are the services which we can like control or monitor or manage, rather. The manage word would be the correct word to use. Manage using our Azure Arc. I'll click on Kubernetes cluster because today we are focused on that. Sometime later we will also cover in some of the webinar about the data services too. You can see a plus symbol here. Add a Kubernetes cluster with Azure Arc. Here it gives you a brief understanding what all things would be needed. You want to add a new or an existing cluster. You need to spin up the cluster and then do it. OpenShift clusters for information. OpenShift clusters also can be registered with Azure Arc. Now, Here we need Azure 𝐀𝐿, which I have installed. You need some 𝐀𝐿 extensions so that you can communicate with your Azure Arc. These are connected 𝐀8s and 𝐀8s configuration. These are the two 𝐀𝐿 extensions which I have installed. I've installed Helm 3. A lot of people might be knowing Helm 2 is outdated and people use Helm 3 these days. So we would be using Helm 3. And here you can find the instructions to install each of them. And then you have the 𝐀𝐠𝐞 file. So what does the 𝐀𝐠𝐶 file help us to do? That's one of the important pieces here. So let me just try and explain that. So I would be creating these clusters, and those clusters I would be connecting from here, right? Like my GKE, I'll connect using my gcloud stuff. My Azure 𝐀𝐿, AWS 𝐀𝐿, I'll connect my AWS cluster. Sorry, AWS cluster is here. The word is confusing. It's EKS and AKS. It's so similar. So my Azure 𝐀𝐿 would get connected like this, right? So I would need to connect them, but so many clusters residing, where are those configurations? I'm not sure how many people know about Kubernetes configuration is maintained in a file called as .kubeconfig file. This maintains the all details of the cluster and user, both the things would be maintained in this. Which cluster with which certificate as which user with which authentication token you would be logging in, that you would be specifying. So I need to have my kubeconfig file populated with all the three clusters, and using 𝐀𝐠𝐶TL command, there are 𝐀𝐠𝐶TL command to list the context. Whenever a cluster is created and a user is attached to it, there is a context created out of it. You will have a context created. So you can check the context with get context command. And then you can switch the context by just typing in use context command and giving the context name. So I would create 3 different contexts, and I would be switching against the context and registering each of them, each of the clusters individually from my laptop's command line interface. From the bash terminal, I would be registering them to my Azure Arc. That's the agenda. So let's start by deploying our clusters. So I'll first start with, say, Amazon. So here I am in EKS cluster. Let me just switch to EKS Kubernetes. I'll search on the top. Let's click on it and get into this. Okay, just give me a second. I think it was being logged in from long, so I'll just log into it on a different terminal and come. Sorry for that. Just give me 1 second. Hope you people are liking the session. Any questions, then please drop in a message on the chat. Capture words itself are not getting entered correctly by me today. Okay. Oh, sorry for it. It's taking some time. Yep, it has logged in. Okay, cool. So I'm here. I had looked for a Kubernetes cluster. So I had typed in EKS. So you saw I had clicked on this. So it has taken me to the Kubernetes cluster service. You can list all the services from here as well in AWS, right? Here it is asking me to give the name of the cluster which I want to create. Let me name it as EKS cluster so that I can identify it better on my Azure Arc. Now I'll just run through all of the parameters as well quickly. I can't spend time on each of the parameters, but I'll try to do my best. So this is the name of the cluster. This is the version of Kubernetes which we are installing in our Kubernetes cluster. When we want a managed service, I want someone else to manage my cluster, right? Someone else in the sense the cloud provider. So the control plane would be managing my AWS resources of worker nodes. And that's the reason you need to create a role. I've created a role and kept it. This role has full control. On my behalf, it can manage my AWS resources, which are linked with your worker nodes, which we would be spinning up. Now, I'm not using any encryption. These are for the keys encryption for the Kubernetes secrets. I'm not doing that. I'll click on next. I'm not attaching a tag. This is the VPC in which my cluster would be hosted. And this is the subnet. I am at present in, say, Ohio, US East 2. And I can, let me just switch to US East 1, if I'm not wrong. Let me just switch to that and then do this process. Okay. I think I've created the keys and kept it over there. So let me quickly check if these roles are visible. Yep. Cool. So we are into this. I'm just reducing some subnets. The worker nodes which gets created, they would be spread across these subnets. I had captured the picture of it. Yeah. This is what we are planning to do. We are setting up our EKS cluster. I would be spinning up multiple virtual machines, which are nothing but an EC2 instances, which would be working as worker nodes. This is the VPC which we have just now given. You saw that I have chosen a region, and in that region, there would be various availability zones through which I would be actually spreading my nodes, which I would be creating. I am just selecting a security group rule so that we can connect to the cluster. I'm just selecting that. And I'm making my cluster endpoints as public. I would be getting public endpoints for my worker nodes. Here you can select the CNI, container network interface. So you can select which type of pod networking would be supported. So we have various varieties of pod networking, right? We are living with Amazon's PVC-based CNI. This is the version of core DNS. DNS helps us in resolving the pod name to the IP addresses or any communication which happens within the cluster. kubeproxy helps us in enabling the service networking. It proxies the packets to the application. That's the work of kubeproxy. So that is also there. I am not enabling any of the control plane logging. I'm just leaving it like that. I don't want the control plane logging to be there. And I think we are good with it. Everything is summarized over here. Let's hit and create. If we have an error, it would be listed over here. So I have created a cluster service role, which has full control on EC2 instances, Tarun, because I want my cluster already exists. The name of the cluster is it. So let me make it as EKS cluster 1. I was just trying out. Okay. Let's do next, and hopefully it creates now. What is it? Let me just see what clusters are existing already. Okay, yeah, I have done that. So I'll just change that to 2. I had removed the worker nodes, but I had retained the cluster. So let me do next, and hit on create. This time it should not crib. Okay. So this would take some amount of time. We would leave it like that. You can refresh it here and see that cluster is getting created. So we are just creating the master part of it. We are not adding any worker node yet. So in AWS and GKE, they have an option AWS, EKS, and GK, they have an option that you have the control plane residing and you don't have any worker nodes inside that. So that option is also there. Later, we'll come here and we'll add our EC2 instances. That is our worker nodes we would be adding to this. So meantime, let me take you to my Google account and create a Kubernetes cluster in that. So in Kubernetes of Google, this is my Google account, you would find that there are two options. One is a standard Kubernetes cluster and one is an Autopilot Kubernetes cluster. I don't know how many people know about EKS based on EC2 and EKS based on Fargate. So when we say Fargate, we are not paying for the worker nodes in AWS as well, right? So the same thing is there in Google as well. If you say Autopilot, here you can see, you would not be handling the entire cluster. They would be optimizing everything. The handling of the worker nodes is also to the cloud provider. You would be just paying for the pods or the application pods which you are deploying. You would be just working with them. So I would be choosing the standard one in which we would be going ahead and creating the cluster and adding the worker nodes into it. So I'll go ahead and do that. So here you got to give the name of the cluster. Let me quickly give cluster, see, I will give a different number. Zonal type or regional, it entirely depends on how you're spreading out the stuffs, the worker nodes. That's the reason I'm just living with zonal. Here you have static version or the release channel. You can see a release channel for auto management of your cluster versions, upgrade, whatever the cadence is normally done on your Kubernetes cluster, you would be just handling it in an automated way. So I am picking up the version of Kubernetes is 19.9 over here. So this is good. I'll add a node pool. I have an option of adding a node pool. Let me just hide this. Okay, so let me just create this. I've submitted. What is it? Okay. I think in my node pools, the default node pool, there are too many number of nodes. I'll just make it a 2-node cluster. And if I have any pools, I'll just make it 0. I don't want to have any pools which has too many nodes. Okay, so my default pool is having 2 nodes and they would be of, I'm taking E2 medium. Disclaimer here, if you are not giving 2 virtual CPU, 4 GB RAM, the Azure Arc agents will not get deployed. So just make sure you're giving this much minimum resource. If you spin up a smaller version of the worker nodes, it will not be able to host them. So I've just kept 1 pool and I've made the changes. Let's click on this. So in this, my cluster would be coming up and it would have 2 worker nodes. This is under progress. Let's go and check our AWS as well. It takes a bit of time. We are expecting everything to be happening or to get that on the back end, right? kubeadm init, kubeadm join, all those things should happen at the back end. At present, the cloud provider is bringing up a virtual machine, and that too, these are highly available masternodes. So 3 masters minimum would be coming up, which would have, say, your Docker, your Kubernetes software, your Kubernetes tools, which helps us to set up the cluster. All those things would be deployed at the back end. So certainly that would take some amount of time. Meanwhile, when these clusters are coming up, let's go ahead and deploy our AKS cluster as well. So taking you to the Azure cloud. And here, instead of going to Azure Arc, this time we will go to the Kubernetes service. You would type Kubernetes on the top and look at the Kubernetes service here. There is an option to create a Kubernetes cluster. Let's click on that. You can create these things from a command line interface too, but I'm just creating it from the portal. I would give a name for it, AKS cluster, say 22 to be on the safer side, and where you want to host, which availability zones you are spreading. The same things were asked for AWS as well, right? And the version of Kubernetes. I'm picking up standard size machines here. I am not changing the size of the machine, and I would just change the number of nodes here, little bit more flexible in configuring the stuffs. All the 3 different clouds have different interfaces, right? You can even choose for auto scaling. This would auto scale your worker nodes when it is actually going beyond the capacity of the worker nodes to handle the workload at that point in time. Now going to the node pools. By default, how we had a default pool in case of GK, like that we have a pool here, which is called as agent pool. And you can see here that this is the size of the machine. So what exactly a pool does? You are creating a Kubernetes cluster. In any of the clouds, you saw that there is a pool associated to it, right? You have a K8s cluster. This cluster can constitute of various worker nodes. So master is handled by the cloud provider and worker nodes. Suppose I have worker 1, worker 2. If they both are the same configuration, I can create pool 1 and specify the size here, saying that 2 virtual CPU, 4 GB RAM would be the size of the machines which run inside this pool. And I would spin up two of that sort. So 2 worker nodes would get spinned up. If I need different varieties of worker nodes, I can spin up another pool. I can say 3 of this sort would be present, and this guy would be having 4 virtual CPU, 8 GB RAM. Then it will spin up 3 worker nodes of this size, of 4 virtual CPU, 8 GB RAM. So you can call them as worker 3, worker 4, and worker 5. You would have other worker nodes. So totally there are 5 nodes in the cluster, and all of them are worker. You can't see the master because master is under the control of cloud provider. This is not with us. We don't see this, rather we can't interact with it. Our only 𝐀𝐠𝐞𝐧𝐝𝐚 command line interface interacts with the API server, which is the API interface for our Kubernetes cluster. Our 𝐀𝐠𝐞𝐧𝐝𝐚 command line interface talks to our API server residing on the master. More than that, you can't go beyond anything accessing on the master. So here you saw that different varied varieties of pools have been created, and that is what this is. The pool name is agent pool. The size of the VMs in that pool is this. And here you can say auto scaling is needed. I would be minimum starting with 2 nodes in the cluster, and on the fly, if there is too much of workload, I may like to scale up to 5 number of instances in my worker nodes, then we can certainly do that. I'm just updating this. Everything is sorted. There are various different tabs here. So I'll just do next. Here, I would be living with service principal or system-based managed identity. What happens? The infrastructure authentication happens. Our Azure Kubernetes service would manage few other cloud resources. Like I would say, expose my application with a load balancer type of service. Then a load balancer on the Azure cloud gets created. So in that case, we need to have authentication. 2 services would be authenticating with each other, right? So that has been specified in this authentication method. Then in Kubernetes, you have the option of enabling role-based access control. You can have a cluster admin, a developer, and dependent on the namespace, you can confine the visibility and accessibility of the users and what level, what commands they can execute in the cluster. That can be controlled. So I'm just leaving it as enabled. AKS can be integrated directly with Azure Directory. I can even do that. I'm not doing it at present. This is the encryption key for our node pools operating system. Whatever OS disks are being used for the worker nodes, it would be for them. I'm going to the next tab here. I would use Azure CNI. You have option of KubeNet as well. In Azure CNI, we would be having Azure's VNet and then the subnets. You can specify the containers containers get the IP addresses from the Docker bridge, you can define their subnet and you can specify what type of networking or what would be the subnet you would be having for your cluster as well. Now, automatically, the default load balancer, the standard load balancer is integrated in case I want to integrate advanced routing with application gateway. I can even go ahead and do that. I'm not enabling private cluster, rather I'll leave it as public. Policies, network policies helps us in controlling pod-to-pod communication, which application can talk to which other application in my cluster. Otherwise, Kubernetes clusters have flat networking, and every container in the cluster can talk to every other container without doing anything in a Kubernetes cluster. So we are going ahead and clicking on Calico. Now coming to this, I can integrate my Kubernetes cluster from here itself to container registry. Container registry is a location where we can save our container images. So it's a private registry which we can integrate with. I can specify the name here, and that also would get spinned up when our Kubernetes cluster is getting spinned up. I'm not doing that at present. I'm just enabling cloud monitoring so that I'll show you how do we monitor our cluster. And here, Azure policy I have not enabled. It would help us in safeguarding our AKS cluster from a centralized location. You can write policies to safeguard our worker nodes and what comes to the worker and all that stuff. So I'm hitting on review and create, and I'll wait for the validation to be successful. Once the validation is successful, we will go and hit on create. So these are the various parameters which are being filled across different cloud providers to spin up a cluster. Obviously, this has been spinning at the last, so it will take some time. Let's go and see the health of our 𝐀𝐠𝐞𝐧𝐝𝐚 clusters. This guy is up, hopefully. Let's see. Okay, it looks like the details are there. It's having a pool. There are 3 pools, but I don't find any nodes in this. I just have 2 nodes in my default pool. Amazing. And these are the specifications of my worker nodes. You can see them. The worker nodes are named this way. They belong to the default pool. You can know from the name itself. Amazing. So my GKE cluster is up. Let's go and check what's the status of our EKS cluster. This guy is also active. Amazing. But the compute is not there. I don't have a node. I just have the master node set up here. Okay. Now coming to the add node group. I'll pick up all the questions. I'm seeing the questions. I'll pick up the questions. Let me just spin up the cluster and I'll pick up the question. We'll take a logical break and we will pick up the questions. So here I am attaching an IAM role again. These roles would be used by the nodes. These nodes would be interacting. These would be self-managed nodes, right? So we would be having some capabilities in this node so that they can auto-scale themselves and all that. That's the reason there is a role attached to it. I am not tainting. I'm not doing anything. I'm just going ahead. I'm just leaving it as T3 medium. I just tried with some smaller size, but the agents of Azure Arc don't come up. They need some sufficient amount of resources. So yes, it's going to utilize some of our majority of the resources which are running on the worker nodes. I am just giving how many nodes I need. Worker nodes 2 is the minimum, maximum is 2, desired is 2. So at any point in time, there would be 2 nodes which would be running inside this pool. I am not defining the scaling and all that stuff. I'm just leaving it like that. I would pick up key pair. Okay, there's no key pair over here. I would go ahead and create a key pair. Let's go ahead and do that. I thought I created a key pair, but I think it is not getting listed over here. Okay, it is. Okay, I have a key pair. Sorry, I missed on that. Okay, so a key pair is there. This key pair would help us SSH to the worker nodes. We are getting public endpoints for the worker nodes. So I have a key pair. If I wish, I can SSH to my worker. Master is alone hidden from us. Otherwise, everything is all accessible. So all the things, this is like the preview and create in our Azure. It shows like this. Let's go ahead and hit on create. So cluster creation was in progress. Now node group creation is in progress, but will come after some time and we will do a refresh and see whether it is in creating state or not. So here at present, it is showing creating. So we are all sorted. Let's take a logical break and see what all questions are there. Let me go from the bottom to the top. Difference between Azure CNI and Kubernetes. Okay, so Azure CNI would be using Azure's VNet, the subnets. They would be created on Azure. The Kubernetes way of networking is different, in which the pods networking, subnets and all, you can't define. You don't have the option of defining the subnets. It would be assigning you the standard ranges. So I'm not sure how many people are aware of the networking part of it. When we have several worker nodes in our Kubernetes cluster, I'll just save this in case we need this later. Let me spin up a new page. Okay. So how it is, the networking. There are two different types of network. One network is inside the worker nodes. Like I would have the worker node. Let me draw two worker nodes. And obviously, they would be connected on a network. And if you guys are aware that inside there is a bridge type of networking in which the containers actually get the IP addresses, right? So this subnet range, you have the liberty of defining in case you have your Azure CNI. In case of Kubernetes, you don't define that. And these guys are connected to this network. Suppose I'm spinning up a pod which is getting hosted on, say, worker node 1. It will grab the IP address from this bridge. Say this is pod 1. And if I have a pod, which is P2, which gets hosted on worker node 2 because of the scheduler, it will get the IP address from the range of this particular bridge. And these bridges are actually connected to the Ethernet interface. So these bridges are actual Linux bridges which are there. They both are Linux bridges on the OS level. And they have a particular subnet. In a Kubernetes cluster, looking at the subnet, you can tell my pod is working on which node. Pod will get an IP address, like I'm just taking a weird example, 10.30.80.0 and 10.40.0.0. If I give a subnet like this. Then this pod would have an IP address of 10.40.10. And this pod will have an IP address of 10.38.0.10 or 9, for example. Now we communicate like this. The communication, how it happens, when we are actually talking from P1 to P2, you are transmitting packet with a destination IP address of 10.40. So when the packet comes to the bridge and it sees that destination IP address is 10.40, it understands it's not on this bridge. So it throws that to the CNI pod. In every node in the cluster, there is a CNI pod running, which helps us in routing the packet to the correct node. So this CNI pod would throw this packet on the overlay network. This is called as overlay network, which is connecting multiple nodes in the cluster. Now, this overlay network would, here the packet's destination IP address will change. From 10.40, it will rather change to node's IP address. Covering has been attached. I would not say the destination address is changing, rather a encryption or a packet gets attached in front of it, right? So if we are using any specific CNI, there are a lot of CNIs in the market like 𝐀𝐠𝐞𝐧𝐝𝐚, VNet, KubeNet, and every cloud provider has their own CNI. The normal networking which they use that. So here the packet's destination IP is having a new name or IP address, which would be node's IP address. When it falls here, it understands this is the node. It sends the packet to the node's IP address. Again, here we look at it, and this covering would be removed. How we have added a packet, now it's time to remove one cover and see the actual application packet, right? So here it will remove that packet and it will find, oh, destination IP address is of P2, which is nothing but 10.40. So it throws that to this bridge and packet arrives on this P2. So this IP addresses, which we are seeing 1038, 1040, I have the liberty of defining them if I'm using the cloud providers one. You saw that we had some options over there, right? You can do that. In Kubernetes, it doesn't have that option here that you can't define the IP addresses. Okay. What if we use the default IP subnet for my VNet? Yeah, you can even use that if you already have a subnet. You can even use that. In those subnet, the worker nodes would get spinned up. Chandrasekhar, you can certainly do that. We can deploy those services together with other cloud providers. Vishwas is asking. Azure Fabric can also be done like this. Service Fabric. So Service Fabric registering with Azure Arc is not there, but yeah, Azure Service Fabric is one flavor of proprietary Kubernetes, you can say. It's not Kubernetes. It's a different way of clustering your nodes. Certainly, yes. Which cloud provider's cluster is best? All of them are very similar, Sanmukha. So it's not that which one is best. Everyone provides different varied features and everyone is competing with each other. So all of them are good. I use all the three. What kind of cluster service role? I had answered this question. Azure Arc is very similar to Anthos. Yes, certainly Azure Arc is similar to Anthos. Vishwas is saying like Swarm is for edge devices and cluster edge computing aspects as well. Yes, it has the edge computing. You can even register K3S clusters. Okay, thanks, Adesh, for complimenting for the tool. Does the screen froze? I don't think we have any more questions. So we will proceed further. Calico agent need to add on all the nodes. Automatically, they would be coming up. In case we are setting up these clusters ourselves, like a non-managed Kubernetes cluster, then yes, CNI has to be deployed or implemented, or I would say deployed rather, not implemented. We would be deploying those CNI interface from our choice. But at present, cloud providers have their CNI. We are just using them. What's the difference between Docker and ECS? Docker is a containerization platform. ECS is a clustering service. It's managing a bunch of containers for us, Mukesh. So ECS will help us manage a bunch of containers. How we have Azure Service Fabric like that. When Kubernetes was not that popular in market and Docker became popular, both the cloud providers came with their proprietary clustering software. One was called as Azure Service Fabric and other was called as ECS in AWS. And later they saw Kubernetes is picking up good market. So everyone came up with Kubernetes as a service as well. Okay, so ECS and EKS are very similar, but the way we handle them, both help us and manage containers. But yeah, little bit functionalities here and there, a bit different. So let's go back and see what's the status. We have picked up questions. I'll just refresh and see if it is yes. My worker nodes are also active. So my cluster name is EKS cluster 2, in which I have one pool and I have 2 worker nodes over here. Amazing. So clusters are up. It's time to get the hero of our show, which is Azure Arc. We can access private AKS cluster. Yes, if you have a jump server in between, you can still register. You should be able to connect your cluster with your AKS, Azure Arc. You would be certainly able to do that. So my AKS cluster is also up. Let's see that as well. We saw all the other clusters. Yes, it is residing in this resource group. The node pools are mentioned here. The agent pool is here. I have 2 nodes, both of them are in ready state. Now let's go to this. Now here it gives set of steps which we need to follow. I would create a resource group called as Azure Arc. Sorry, I missed a RG, and just say OK. I would have the name of the cluster. So I'll pick up the cluster name, 𝐀𝐠𝐞𝐧𝐝𝐚 cluster 22. Let me name it the same, how I've named it. So here, if you have a proxy, outbound proxy, behind which your actual server is serving, then you have to do some extra settings. Otherwise, everything else is sorted. I'm not giving any tag at present. It gives us a script. This you got to run in your setup so that you can integrate your Kubernetes cluster with your Azure Arc. So what it expects us to do AZ login, set up the subscription of mine, just create a resource group, and then go ahead and connect. So here it has given everything. Before to that, let me just go ahead and get the credentials and all set up. Let's get that terminal of mine. Let me see, where is that guy? Okay. So my system was troubling. I'm using Shivam system these days. And yeah, so what I expect to do, just give me 1 second. I also don't remember all the commands, so I'll just quickly pick up the commands from the. I would go and get my credentials of AKS. My AZ login has already been done, but still I'll go ahead and do it. Let's see. It will open up a window. I'm just pressing here. Okay. It has popped up on the other screen. That's the reason you people didn't see. And let me go and set the subscription which was being given, because both of them are in the same subscription. I'm just minimizing the windows which we would not be using now, so that, okay, let me get the credentials. So we need to get our Azure Kubernetes clusters credentials. I mentioned about kubeconfig file, right? So I'm getting credentials of the AKS cluster so that I can interact with it. I need to specify the resource group and the name of the cluster. So let's quickly do that. Let me even minimize this guy so that. So I have that on our other window. Let me go ahead and pick up the details from here. So resource group name is AKS-RG, and hyphen name is for the cluster in which I would give this name. And I will grab the credentials of my AKS cluster. Okay. So you see this, there is a file which has been created. Let me scat this file and show that to you. So you can see here I was talking about this. You would be interacting to this cluster. This is cluster certificate, the name of the cluster, the DNS of that API service where you would be connecting. And here is the context. The context specifies to which cluster as which user you would be connecting. And this is my user certificate and the key. So this is just having one cluster data now. And if I execute kubectl command, kubectl config get contexts, I just have one cluster and I have one context. This context is picked up from this kubeconfig file. So whatever commands I execute, kubectl get nodes, it will list me all details about my AKS cluster. I want to show you something. I want to show you get namespace. I don't have a namespace called as Azure Arc at present, but once you register your worker nodes, or rather I will say the Kubernetes cluster to your Azure Arc, you will find a new namespace gets created and a bunch of pods would be running inside that. So we would see that in a while. Our clusters which are listed with Azure Arc can be dumped with this. So I would give the resource group of my this. Let's go to this. What's the name of the resource group which I gave? Let me pick up this particular stuff, and there is no resource group either, right? I have not executed those commands. So let me quickly do that. I had set this. I'll create a resource group and then I can connect my cluster to it. So this is creating a resource group. This resources group is for my Azure Arc. I'm creating that. Now, if I list the above command, it will say no clusters are registered. It's an empty list. My present cluster context is pointing to AKS cluster. In the get context, you can see there is only one cluster, and here the current is having an asterisk. That means this present cluster is actually pointing to my AKS cluster. You have a command, az connected, connect, give the name of the cluster. Let me give the name of this cluster, AKS cluster 22. And then we would give the resource group name. I've created a resource group called as Azure Arc RG. I will give that. I'll give resource group and give the name of it. And then I'll give the location. Let's give the location. Hopefully I'm not making a typo. East US. And press enter. This will take a while. It is now registering our AKS cluster to our Azure Arc. I'm not sure if you people are able to see this yellow color stuffs. It says that it is using Helm to install. So what exactly is Helm? When we want to deploy several different applications into Kubernetes, instead of writing separate YAML files for them, we develop charts. And these charts help us in deploying the applications in a quicker way. So we have chart built up already for Azure Arc. That means my agents will automatically come up if I am using this. With this, at the back end, there is a Helm template which is being used, which is going and deploying our Azure Arc agents into this cluster so that Azure Arc can manage that. So I'll just leave the screen here. Let's go to Azure Arc and just do the verification. You see this? Already this cluster is showing up connected. Here I've not got the prompt back. It will take a while. It will come up with the entire registration process. I'll go to the cluster from here. I can go. So Azure Arc would have your Kubernetes clusters listed here. Just refresh the screen. You should have your Kubernetes cluster listed here. I think the subscription is not correctly selected. Let me quickly do that. Yep. So you see this guy is registered. These are older clusters which I had connected, which is giving it a try. This is the cluster which is registered now. At present, it should be connecting, not completely connected. And here, last connectivity. From time to time, the agents would be going and talking, right? So I'll just wait for the prompt to come back. Yes, it has come. That means my cluster is registered. Provisioning state has succeeded. My AKS cluster is now registered. Now let's list. See here, it is saying in this resource group, I have a cluster registered as this name, and it is in this location. So one cluster is registered with our Azure Arc now. Hopefully everyone is good with it. Let me just check. I don't think. Okay. Shiva, that's a very huge question. What's the difference between a Kubernetes and a Docker? You need to come into the basic sessions of Kubernetes to know that. This is something advanced. Sorry, I can't cover that, but Kubernetes helps us in managing a bunch of containers, a fleet of containers. So now this is done. Same way, how did I register my Kubernetes cluster of Azure? I would go ahead and register my GKE cluster as well. Let me just confirm what was the name I gave for my GKE cluster. Hopefully the region and all is same, so it should fetch. It is fetching, and it has updated the same config file. Now see the difference. kubectl config get -contexts. Yeah, you would find two different clusters here. Earlier there was only one. Now you have this GKE as well. And my context immediately got switched to it. Now, whatever command you execute with kubectl, it would be getting listed from the GKE cluster. So I didn't show you one thing. I'll go back to my Kubernetes cluster of AKS and show you the agents meanwhile. So you would say use context when you want to switch the context and give the context name. I want to go to this context. You would see that the asterisk symbol, which is there, it would be switching from here to here. Earlier, it was pointing to GK. Now it points to AKS. Now we had listed kubectl get namespace last time, and Azure Arc was not there. So let's try doing that. You see a Azure Arc namespace. Namespace is like a resource group of Azure where we can bundle a set of resources and we can manage them better. And sorry, I can even get all resources which are running as part of the Azure Arc namespace. Let's do that. Hopefully all of them are running. It's taking a while. Yep. Okay, we are safe. They are up and running. Few of them have been deployed as deployment. Few of them have been having a service for the connectivity. And these are the agents which are actually running. So these agents would be helping us manage the cluster. I'll come to each of the agents later. I'll explain what these agents are doing. Meanwhile, let's quickly register our other cluster as well. So I'll do get context. And I'll switch the context this time. The name of the context which has got created for GKE is pretty huge. We got to give this name. I've switched. And let's do kubectl get ns. You would not find a Azure Arc. So here Kubernetes cluster is there, but it is not registered with our Azure Arc at present. Let me quickly go back and execute this command. So what we have to do, it's pretty simple. Now I would give the GKE cluster name. You can go from the portal as well. You can do it from here too. So my name of the cluster is, I would be naming that as GKE cluster 22. It picks up the context of the cluster from here. So I think I've switched to the context. Okay, yeah, perfect. So I've switched to the GKE context and I'm saying, register this GKE cluster with this name. This name which we are specifying, that name gets listed in the Azure Arc. It's a name for the Azure Arc. It's not for naming the cluster. So let's quickly do this. The present cluster, which is the context, present context, that will get registered with our Azure Arc. That's the reason switching context is very important. Do the switch context properly so that you know on which cluster you are and which cluster you're trying to register. So this will take a while. I'm just waiting for the other yellow lines to come in. It's taking a while. Let's go back and check over here. They are not yet there. It should get registered in a while, and just patiently wait for it. And same way, we can go ahead and connect to our EKS cluster as well. Feature couldn't be enabled. No, this is a normal statement, prerequisite and all that stuff. Let me quickly refresh here. The guy should be there. No? Okay. So let's wait for it. Meanwhile, let me, I don't want to switch the terminal. So let's wait for it. So Azure Arc, if we just discuss about the different features, right, of different cloud providers, Anthos is there, which helps us in doing it. AWS has also come up with EKS distribution, which is a competing service with Azure Arc. Every cloud provider is coming up with support for on-prem and support for other cloud providers. So Anthos was the first one in the leak. And after that, Azure Arc has come in. And now EKS has EKS distribution as well. Yep, this guy has come in. I think it is still connecting. Last connectivity is not showing up. So we will wait for the connection to succeed. After that, you would see that it populates this. And then you can see all the stuffs here. All the resources can be listed. We will see about GitOps as well, a little bit. So these clusters are there. The cluster is not connected to Azure because I've deleted it. I've deleted without deleting the connection on my Azure Arc. The cluster is actually not existing anymore. I had just tested and I have deleted it. But here the corresponding mapping, which is created on Azure Arc, is not deleted. Here it says cluster is no more there. So if you want to just delete the mapping, you can go ahead and do that. This guy should also be deleted. This is also not existing. So I'll just clean up this so that we are not having unwanted clusters. It'll take a bit of time. You can check here in this bell symbol. It will tell you what all actions are in progress. Here, the bar is scrolling. So GKE22, AKS22, both of them are getting registered. Let's see if this guy is connected. Last connectivity, yes, we should have got the prompt back by now. So we are all sorted. It's not a limitation, you would say, Bijo. Anytime when you are talking to the cluster, you would be on that context of the cluster. Otherwise, you can give hyphen, and you can specify the context as well. So I don't want to specify the context. So I am just making sure I'm at the correct context and executing. Any kubectl command as well when you're executing, if I'm doing kubectl get pods, or I'm doing kubectl get pods, or say on a specific namespace, nothing is there in this default namespace as present, right? So I say kube-system. It runs that command on that particular context. And that is how we people maintain. When a person is managing several clusters altogether, I would not be having 10 different kubeconfig files. I'll just have one. I will have context in that kubeconfig file, a context mapping to a specific cluster as my user. And when you execute the commands in that context, that is actually running. So my connected K8s is picking up the config context from the kubeconfig. Okay. Okay, so these are a few of the resources which are running on our 𝐀𝐠𝐴 namespace. You can see Stackdriver and metric server, FluentBit, and all that stuff. These are GK metrics collection and log collection tools which run as containers on the Kubernetes cluster. So 2 of the clusters are registered. Now it's time for our AWS cluster to get registered. Let's quickly do that as well. So I would pick up my EKS cluster. I'll just confirm which is the region, US East 1. Okay. Here the command is a bit different. It says update config, and you have to give the name of the cluster. AWS like configure, I've already executed, so I'm not doing that anymore. It's connected to my AWS, it has added to kubeconfig. Now let's try chatting this file. You would find 3 different details. This is my 𝐀𝐠𝐸 details. Then you have my 𝐴KS details. Then you have my GKE details. All the 3 cluster details are present in the kubeconfig file. And same way, if you look at the context, you should have multiple contexts now, and the context has switched to EKS. So we would register that in a similar fashion, the connected command. And here I would give the name of the EKS cluster. You can give any name here. It doesn't look for the same name, but I would give something which I've given over there so we can correlate. But now it will go and connect to my. So see the beauty. I am using 𝐀𝐠𝐞𝐧𝐝𝐚 command. It is connecting to my AWS, right? AWS account. It is able to spin containers in my AWS Kubernetes cluster. That's the level of integration we have done now. So here it should come up. If I go back here, I should have my AWS cluster in a while getting registered over here. Let's wait for it to come up. Yeah, so Bijo is saying that I'm a person who uses multiple kubeconfig at the same time and uses --kubeconfig option. Yes, you can do that. You can just type in AZ connected KTS connect --help and look for various parameters we can pass through it. If there is an option to supply that kubeconfig, certainly you can do that here as well. I've not tried it myself, so I'll also will have to look into the help to tell you about it. So let's see if it is registered. Oh, it has come. So whether my cluster is in AWS, whether my cluster is in Google, all of them are getting listed over here. It's so amazing. And here you can see the insights. You can check the insights as well. You can go ahead and check your monitoring. You want to configure Azure Monitor, you can go ahead and do that. It will ask you to configure a specific workspace so that it can have that log analytics captured over there. So here it says it takes around 5 minutes. I'm enabling this Azure monitoring service will provide me matrices, traces, everything of which cluster? A cluster which is running in Google. How amazing is that, right? So we would be waiting for some time. It is just onboarding this. So for Azure Kubernetes cluster, we had already done that. Let's see if we have some traces in it. Why didn't it pick up? Okay, let me quickly do that. Let me do that for all of them, rather. Let's see, when pop-up came, it is registered. Hopefully it was this guy who shows that I'm registered. No. Then it should be Azure Kubernetes, which is saying I'm registered. Okay, all of them are taking some time. So clusters are registered. This is the way you work with Azure Arc. Now, the second step. You have registered them. Now, next what? Next could be I'm deploying resources in it. I can do that in a several fashion, right? I can have my Kubernetes YAML files in my local system. And I can have execution of commands from my command line interface like kubectl apply and create a resource in it. I can do that. Let me see if I have git link over here from where I can go ahead and pull. This is a fresh system, so I'll just pick up this repository. Okay. Okay. Let me do a git clone here. This has a bunch of files. It's a small k. So one way would be to go ahead and deploy these resources manually with a 𝐀𝐠𝐞𝐧𝐝𝐚 command, right? So 𝐀𝐠𝐞𝐧𝐝𝐚 config get context, always get gets typed in the beginning. Contexts. At present, if you deploy anything, it will go to your EKS cluster. Let's try deploying some application. A very dummy type of application. I'll go ahead and deploy 𝐀𝐠𝐞𝐧𝐝𝐚 create -f. I'll just create an application which is defined in this. I'll show you that file as well. It will create a deployment and a service for my application here. So you can see there is a hello world application. If I go ahead and do 𝐀𝐠𝐞𝐧𝐝𝐚 get all, the resources have been deployed in our default namespace. So you should be able to see that. Okay. So container is in creating state. Let's see if it is coming up and running. I can put a pod watch as well. I have not created a load balancer type of service. That's the reason I don't have a service with an external IP address. So I'll do one thing. What will you do if you have done something like this and you want to edit it? You would go ahead and edit your file. Let's see the file. We had plans to see the file. I'm creating a deployment. Deployment helps us in creating a highly available application. I would change the number of replicas to 2. For example, I'll run 2 replicas of this application. It's a small application which says AKS hello, AKS in Grace demo. And I would be changing the string. I would be going ahead and changing this to load balancer tag. So what happens? We know this is running in our EKS cluster, right? If you go and verify the context again, I'm in my EKS cluster. So whatever commands I'm executing, that is going and deploying resources in my EKS cluster. Now let's see. I've made the change to the file, but I've not applied that change to the cluster. So things will not be updated on the cluster's etcd. Let's do a apply with -f, give the file. And these changes would be again pushed. Whatever delta changes are there, they would be pushed to the cluster. I would be having, say, deployment updated with 2 replicas and service upgraded to load balancer tag. That's the expectation. Let's list it. Get all lists, most of the resources, some of the resources like say the config map, the PVC doesn't get listed with it. It's taking a while to list it. It's not in a mood to give the output. Azure Arc billing, how it happens, we would see that. It doesn't charge us for any of the registering of the cluster. In case I'm enabling your, say, the log analytics and all, the log analytics services charges would be applicable. If I'm managing 1 cluster, I'm having 2 clusters, 3 clusters, log analytics charges would be applicable for that. As such, Azure Arc doesn't have any costing associated to it. But if you have a configuration created, then it would have. I'll show you how to create a configuration. We have not seen GitOps yet, so we would see that as well now. Okay, so you can see I have load balancers name over here. Let me go to this and see if my application is up and running. Hopefully, it's not a bad day for the demo. Let's see. Okay. So this was serving from my EKS cluster. Correct. So this is done. This is one way of deploying your application. Now, if I want to deploy in a GK, I'll switch my context. I'll go ahead and deploy my resources to that. But if I want to implement a set of bunch of files, lot of stuffs, I want to create it in a one shot. How do I do that? So we have something called as GitOps. Let's see what exactly it is. As the name says, it is GitOps. So you can select one of the clusters. You would find a GitOps option over here, and you can create a configuration. Your Azure Arc has a costing associated with this add configuration. If you're adding a configuration, then you would be having the charges, otherwise not. If you're not adding any configuration, you are just looking into, you're registering the cluster, but what will you do registering a cluster, right? If you don't deploy anything into it using this interface, if you don't look into the logs, like every logs will get poured into your log analytics now. If I don't do that, what will I do with just registering it? So as such, registering is not charging us, but other services which we are integrating with our Azure Arc, yes, certainly they would be charging. Now, I would take you to another GitHub link of mine. Okay. I'm not sure. I'm not able to post the message to the chat. Let me give it to Shivam in case he can post it. So Shivam or 𝐀𝐠𝐞𝐧𝐝𝐚, anyone, if you can help.
Yeah, okay, I am here.
Yeah. So if you can give them the Git link for.
Okay, I'll put that in the chat.
Thank you. I'm unable to post messages on the StreamYard chat. Sorry for it. So here, if we see, this is a link in which there are several different files mentioned over here. You can find there is a team-related file called as Team A. I'm just creating a config map. There are different kinds of resources which we can create. I'm creating a config map, which would be named as endpoints. It would belong to a namespace called as Team A, and it would be having this as the key, and this is the value to it. This is another data. This would be the value to it. So how will you do? You would normally, what we did last time when I had a YAML file, I picked up the YAML file, I went ahead and did the kubectl create, right? Instead of doing of that, I want to implement that in one go. I have a bunch of files. I want to implement all of them. And from next time onwards, if I do any delta changes, I would be updating that as well. That also needs to reflect to my stuff. So this is one Team A file. Then there is a namespace. Obviously, when I want to create a config map, I need to have a namespace called Team A. Otherwise, the config map will not get created. So there is a ITOps file, which is creating a namespace called as ITOps. There is a file which is creating a Team A namespace. And there is another YAML file which is creating TB namespace. So if I execute these files, what will happen? There would be 3 namespaces, and there would be a common a config map created in the Team A namespace. Now there is another application running in the cluster apps. It's not the voting application. The voting application was a little bit bigger application. Just before the demo, I saw that the image was not working well. So I've just picked up a dummy application like this, which would be deployed in a highly available way, and the service is getting created. So I want to build or deploy all of these things in one go. Okay. So I would be going ahead and deploying all of them in one go with one specific command. Let me quickly pull that command. It's a huge command, obviously. Okay. So for this, you will have to add that 𝐀𝐠𝐞𝐧𝐝𝐚 configuration extension. This is already added in my command line interface. I'll go here, but I'm just giving it for your reference. 𝐀𝐀𝐻 configuration, we would be creating a configuration. So I'm picking up the command and I'll edit it with respect to whatever cluster we have. So let's see what all parameters are there. Let me do Control-A, go to the start. So AZ 𝐀𝐻 configuration, I'm creating a configuration. I am creating a configuration with the name cluster config. The cluster name I'm giving. And on which cluster do I want to push these clusters, this configuration changes that I'm giving. So here I'll give my cluster name. Let me quickly pick up my cluster name. I'm forgetting that. I think it is 22. The resource group name in which my Azure Arc resource group is residing. This is not this. We have to correct this. So let's go back to our Azure Arc and pick up this resource group name. Come back here, give this. And then you have the operator instance name, the operator namespace name. So there are few operators which are already running, the agents which are running, right? So we are giving few things related to that. And we are giving our repository URL. You see this? I'm giving my GitHub's repo URL, which just now Shivam has pinged on the chat for everyone. So that particular Azure Arc set of files which are there, that would be getting deployed in this cluster. Let's try and do that. The scope is cluster and the type is connected clusters. I'm deploying this into the connected clusters. Let's see if this works. Okay, it would show that it is in a pending state. Let's go back to our Azure Arc and go to here. The config should get created. You see this, the config, cluster config has got created here. And at present, it is in pending state. From the single command, I can deploy several YAML files to my cluster. I can even do Helm template deployment the same way. I picked up the YAML file. There is a single command to do the Helm, say the template deployment too. So this is at present pending. It will take a while till the time the resources come up. It will be showing pending. So here you would see it is showing pending here as well. After some time, we'll go and see the resources which are running. I'll just switch my context as well to my AKS cluster. And I'll do kubectl get pods. And I'll do get all. I do get namespaces as well. You see this? This is getting created at present. The YAML files, which is in my GitHub link, they are getting executed on this cluster. If you do kubectl get namespace, you should see those namespaces, team A, team B, IT ops, those have got created. These are the ones. And this application is also getting deployed. We had created a service and we had created a pod. You can go ahead and do that. We had created a config map as well, right? So you can go and check the config map, which was in team A. I think it was in team A namespace. Let me just list that. kubectl get 𝐀𝐠𝐚 -end team A. Yep. Endpoints, it is having 2 data. You can even describe and check everything is sorted. I would describe the 𝐀𝐠𝐚. 𝐀𝐠𝐚 name is endpoints. Let's confirm that everything which we had created, it is working as expected. Yes. So here you have logs as the keyword. This is the value. This is the key. This is the value of the config map. Cool. So all the related resources have got created. Now what it is, I would be going ahead and updating. So what a developer does, a developer would have cloned the repository to the local, and then whenever they want to make any changes, they will push the changes to the Git, and automatically that changes will get reflected over here. We want to simulate that particular stuff. So I would not do a Git push and all, rather I will do a shortcut method here. I will go ahead and edit from here itself. Normally we don't edit in the remote, but I'll do that. And I'll change this type. I think it was, okay. This guy is load balancer type. I didn't notice. Okay. We have an IP address for it. Let me quickly go and access the application. Okay. So this is running in EKS. This is running in AKS. Nice. I am changing that to 2 replicas, or rather I'll make it to 4 replicas. I want my applications to have 4 replicas now. Where am I making changes? I'm making changes to my Git URL. With some time latency, you would find here that these pods will get updated in this cluster. I'll put a watch over here so that we can find them getting created. So I want 4 replicas. Earlier, I had just 1 replica. So what changes I would be committing on my Git URL from the local, I push the changes of my file, or whatever changes we are doing on the remote side. Anyone else has put the changes, those would be reflected over here. So after some time, you should see 4 replicas running of the same application behind a load balancer. And we have seen the load balancer's IP address. This is the work of GitOps. Using this, you can run the resources in your other Kubernetes clusters as well. I am running this in your AKS cluster. You can run the similar application, the similar GitOps things can be done on your EKS and GKA cluster as well. I'll just stop this watch command and I'll execute the same in my EKS cluster and show you deploying it over there. So for that, this command remains same, apart from what? I need to change the cluster name. Every cluster has a configuration associated to it. If you see here, inside this cluster, I have the GitOps. Azure Arc is having all the clusters. This cluster's GitOps is empty. I don't have a configuration created. I can create a configuration with the same name as well over here, right? So I'll go ahead and do that. So let me just change the name of the cluster. EKS cluster 2. EKS cluster 2 is residing in Azure Arc's resource group. To that, I'm tying up a cluster configuration. I'm saying that files which are present in this GitHub, they are the ones which are actually getting deployed in this cluster. Let's go ahead and do this. This will now connect to my AWS EKS cluster and will deploy the same things. It will go ahead and create a team A, team B, IT ops namespace, create a configuration map, and deploy the application. All those things would be done in this cluster itself. So single place, you can manage a lot of stuffs. So we will wait. I would just check what's the status of the pods. My kube context is still the previous one. So you can see my kube context is still the AKS one. I'll just confirm that by showing you the get context. We had changed number of replicas to 4. So 4 replicas of this application is actually running in my AKS cluster. At present, I executed the Azure Arc command to integrate that GitOps configuration with my EKS cluster. But to dump the output of the resources which are running in our EKS cluster, I'll have to switch my context. So I'll quickly do that. So difficult to switch context from here to there, but don't have a choice. Life is pretty simple compared to before, but still complicated. So I'll do get pods. Do we have anything? Yes. So these two containers I had manually deployed, if you people remember, which was serving from here. And now these are the 4. Now my file is having 4 replicas. Now, if I make any changes, it is going to impact both of my clusters. If I'm going to say deploy 5 replicas, it is actually going and updating that same set of configuration in both of my clusters. From a single Git URL, I would be able to make changes to both of my clusters. So imagine that you have clusters like this in various different environments, and you want to manage them from a central location. You can use GitOps. It's a easier solution. I would just dump the namespace to show you that it is reflecting. And I will also pick up the service. There are 2 load balancers. One load balancer we have picked up. It says, hello world. We can certainly deploy a multi-microservice, a complex type of application, but just because our focus today is Azure Arc and not application or microservices, that's the reason I'm not doing that. This is my AWS load balancers link. This is another AWS load balancers link. This app is not managed by GitOps. This app is managed by GitOps. If you're making any changes, it should reflect now in both. Let's try that out. Instead of 5, let me make it 4. Let me make it 6 and save it. Or even I can say this makes more sense. So I want 6 replicas, but they would say a different message now. So let's commit this. I've committed the changes. Let's go back here and see what's exactly happening in the cluster. It will take some amount of time. Too many integrations are there, right? One guy is running in Git, another is in Azure, one is in AWS. So the changes reflection obviously takes a bit of time. So we'll just wait for it and it should get updated. Meantime, by the time this is getting updated, let's go and see the list of agents which actually run in each of the clusters and try and understand a brief overview about what responsibilities do they play. So for that, you will have to dump the pods, but you would have to dump the pods from Azure Arc namespace. So how does this Azure Arc help us manage, right? There should be someone running in your EKS cluster or your GKE cluster, which is helping us manage these things. And that is the set of containers. If you do get all, you would see all the resources which are created as part of Azure Arc namespace. Whatever things are created in Azure Arc namespace, all those things would get registered. So you have a metadata operator, you have a connect agent, identity operator. So let's see what exactly these guys do. So let's start with the identity operator. I'm not going in an order in which it is listed. Rather, I'm just picking up in a random order. Cluster identity operator. This guy is the first guy which first initiates the outbound communication. The first communication which fetches the service identity certificate. Agents would be using this for communication going ahead. So that is this identity operator. That's the reason I started with this. Then you have the config agent. Next to it, you have a config agent. You see that? This is just like a watcher type of process. It watches the connected cluster for any configuration changes which are applied to the cluster. And it updates the configurations which are changing in the cluster. That's the work of config agent. Then next to it, you have the controller manager, this guy. Like how we have a controller manager for Kubernetes, we have a cloud controller manager. Like that, we have a controller manager, a controller which will help us orchestrate the interaction between Azure Arc components. So this guy is just managing rest of the components of Azure Arc. Then you have the metrics agent, this guy you see here. The metric agents collects the matrices of all the Azure Arc agents, and it makes sure that optimal performance is there. That's the work of the metrics agent. The first one, the metadata operator, it gathers the cluster's metadata. You saw when the cluster got registered, few things. The first guy with this, you get identified or authorized, and then you go ahead and collect the metadata of your cluster. So version of the cluster, how many nodes are there, what version of Kubernetes Arc agent, Azure Arc agent is running, all those things are managed by this metadata operator. Here, when we were listing the clusters in your Azure Cloud or in Azure Arc, you were getting these details, right? These details, whatever details you have about the cluster, everything is fetched or maintained by that metadata operator. So this is about the metadata operator. Then you have Flux log agent. This collects the log from the Flux operators. This is the log agent. Its work is to collect the logs. This also gets deployed as the part of the source control configuration. You have something called as extension manager. We have Helm charts to be deployed. Helm charts deploy these resources. So these helps us in managing the extension of those Helm charts and few other stuffs which we want to do. Then you have the which one are we left with? Okay, the connect agent, I think we didn't cover this. Cluster connect agent, it's like a reverse proxy agent. This is the guy who helps us to connect to the API server of the cluster. Understand that instead of we going and interacting with our AWS EKS cluster with kubectl, Azure Arc is now going and talking to it. So where will it go and communicate? It will go and obviously communicate with the API server of the cluster, right? So this guy helps us in communicating with the API server of the cluster in which we are. Like these are plus per cluster, right? I've dumped this for the EKS cluster. Like that, you have these servers or these containers running in GKE, you have them running in other clusters as well. So whichever cluster you deploy and you manage that with Azure Arc, this bunch of services or this bunch of pods or resources are bound to run on them. If they are running, then your Azure Arc can manage. I was stating some time back when we were spinning up the cluster, saying that if I'm not giving a 2 virtual CPU, 4 GB RAM resources to my worker nodes, Azure Arc agents will not come up. You would find them in a pending state. These guys will not come up. They will be showing pending. And if you go and look at the resource, why it is pending, you would just debug. You would find that they don't have sufficient resources to actually get deployed. And that's the reason they don't come up. So just note that whenever you are using Azure Arc as the agent, the minimum size which you need to have for the worker nodes is 2 virtual CPU, 4 GB RAM. So Azure Arc enabled Kubernetes cluster is managed with the help of Azure Resource Manager itself. Azure will track all the resources which are registered under this set of clusters. And you can look at the monitoring as well. We had enabled monitoring. Let me quickly go to that and see if we have some view for you. Oh, it is experiencing some delay. Okay, let me go to Azure Monitor. And from there, let me see if I have containers inside. And in that, if I see the clusters, yeah. Clusters are monitored, but somehow they are not reflecting over there. You can see the healthy state, not healthy state. If something has failed, it doesn't have the state over here. You can find them getting registered here. So this is having a double entry. At present, it is showing healthy. I'm not sure why it is doing this way. Let me just refresh and see. Okay, it's still showing double entries. Okay, so I'm just clicking on this. you can find node level CPU utilization, node level memory utilization, how many nodes are there, whether they are ready, whether they are not ready, total counts of nodes, all of them can be listed here. If there are any pods running in the cluster, total number of pods, how many are running, you see them, they have scaled up from say 917 to 1010. We have increased the number of pod counts. If they are in pending state, which pods are in pending state, you can see them. If they are running state, there are different colors to denote that. You can check all of them over here. Now, this is the cluster level view. Node level data also can be seen over here. You can go to each of the nodes. You can grab more details about it. What all pods are running, you can check over here. You can even go and filter out with respect to memory, CPU, and other stuffs. Controllers, if we are creating any of them, that also gets listed over here. Like you have a deployment controller or STS controller. They were the flux operator, log agent operator. It was part of the controller. So all of them gets listed over here. You have containers, all the containers running in the clusters would get listed over here. You can manage them, everything from here itself. You have namespaces. What all namespaces are there in this cluster? All of them would show up over here. These are the namespaces which are present. You want to get further details about that namespaces. It will give you an overview. All those things can be seen from here itself. So Azure Monitor would help us in monitoring the resource utilization, all those things. And here on the view all cluster level, you can see all the different clusters in the single place. From here itself, you can say if something is healthy, not healthy, what are the different number of nodes, how many pods are running, how many system pods are running. System pods are the kube system pods which are running, right? So how many of them are running, those can be seen from here itself. Somehow it has not grabbed the data of GKE yet. It should populate it, and it entirely depends on the sync which has happened. At present, these are the stuffs, right? You have this GK, you see this GKE is showing one unhealthy and one is showing healthy. So the guy which is healthy is actually the correct one. And you can see the node level stuffs here, cluster level stuffs here, same thing. And all these things, if you have any alerts, you want to create a new alert rule, you can create it from here. You want to see the matrices, you can do it from here. You can create charts, you can populate graphs and have a view of your utilization of all resources and everything from a single place of Azure Monitor. My cluster doesn't even run in Azure, but I can manage them or visualize them or like have a view of all the different clusters from a single space from my Azure Monitor. That's the beauty of it. I think I've covered almost everything. We are left with 15 minutes. Anything else if we are pending with? Let me just quickly check. I don't think. So yeah, this is all about today's session. We learned to spin 3 different types of clusters in various different clouds and then registered all of them with Azure Arc. And now we have seen how to see Azure Monitor as well. If what happens, there are a few questions. If we have 10 repos, then we do 10 different configuration. Yes, Prashant, you would do 10 different configurations. Thank you, Amar. Apurv is asking a question for AKS. This is already available in metrics. Would I get similar view of GK in an AWS? Yes, I showed you that. Azure Arc's pricing is completely dependent on the configuration. Dependent on how many configs you create, they charge you according to that. How complex is the configuration, what all you are creating. The configuration management is actually the charges, Jane. So you can look for Azure Arc pricing. To be very frank, I too have not deep dived so much into it because there are different services which this guy manages, right? So there are pricing, but there are pricing with respect to the configuration. Any number of clusters you connect and organize, there is no extra cost. Cost is only for Kubernetes configuration, and they are charged for that configuration. This is with respect to Kubernetes. With respect to data services, with respect to servers, then the charges would be different. But for just registering, they don't charge. You can see here, Kubernetes configuration, first 6 virtual CPUs are free, and after that, this is the charges. Control planes functionalities, it's anyways free. Azure has been very, good in giving us AKS as well without any standard charges as well. Yes, Prashant, it is Flux which is doing the job at the back end for GitOps. Yes. So, yep, this is all about today's session. Hopefully you people liked it. Anything else? Let me see if I have a few things on my slide to cover. So I had kept the architectural diagram. This is what we have done at present. This is this entire stuff. You can even register a Rancher cluster, K3s cluster, or Kubernetes cluster running in any infrastructure, including on-prem. You create configuration like this, and with the help of Flux and the Helm operators, you go ahead and deploy the resources. So every time you make a change in your Git repository, it would be reflecting those changes to your cluster. So you have defining the desired state of your application with the help of these YAML files, right? Whenever you change the YAML file, the desired state of your cluster changes. And a few things which we did for cluster registration, we made sure the kubeconfig file was correct. It was pointing to our cluster. We had proper permissions. We had connected those clusters to our Azure Arc. We did that with the command of connect 𝐀𝐠. Before to that, I ensured that Helm 3 is there because the agents which got deployed in the Kubernetes clusters of Azure Arc agents, they were deployed using Helm charts. So Helm 3 was there in my system. Azure CLI was there in my system, and I had installed the extension of connected 𝐀𝐠. So these things we have done. Now that's about today's agenda. A few more things just to update you people. I saw that from time to time, Shivam was updating these things in the chat. You have Pact is sponsoring our webinars. It is giving us discount codes. There is a quiz running. We expect you guys to participate in that quiz. We give away Azure exam vouchers and Pact books, ebooks, to our winners of the quiz. So please do attend the quiz. It's very simple questions, quite a few number of stuffs we have already covered. Now, I've compared that across services, across cloud providers as well. If you're missing out on that quiz, you're not the winner. Still then, you get a 25% discount. You can use this discount coupon code and buy in these 2 books. Automated Machine Learning with Microsoft Azure and Data Modeling for Azure Data Services. These days, data and machine learning are very popular in the market. So this discount coupon is allowed or applicable only just for a month. So please go ahead and grab this opportunity of buying these books in a discounted rate. We have started, like 𝐀𝐠𝐞𝐧𝐝𝐚 has started a series of webinars. Today was the first webinar of the series. We have named the series as 𝐀𝐠𝐞𝐧𝐝𝐚 series. The first webinar was on Azure Arc. The second webinar, we would be talking about how to deploy modern applications into your Microsoft Azure cloud and how to manage them with various different services. So we would be doing that. Next, we are coming up with a Google Cloud for a different flavor. We keep doing Azure, so we thought we will come up with Google Cloud. So we are talking about how to build, deploy, and scale machine learning models with Vertex AI on Google Cloud. Then the next webinar in the series is about cloud-native applications with Azure services. How do we build and deploy them? We would be picking up a complex application and we would be mapping them to various different services, managed services plus infra services we would be using, and we would be deploying them in AKS, plus we would have Cosmos DB and say Azure functions and other integrations of different services of Azure. Then next in the series, in the month of August last, we are coming up with another webinar, which is related to MLOps, which Shima was talking about in the beginning. Automate and accelerate your machine learning lifecycle. We would be talking about MLOps integration with AKS in this. So these are a set of webinar series. We expect you to stay tuned to it. We come up with latest topics, and we want you guys to join us for 2 hours, spend some time with us, and provide us feedback if you're doing good, not doing good, you're liking our sessions, not liking our sessions. As I mentioned in the beginning of our introduction, that we are a training and a consulting company. So we do corporate trainings, but we also do retail batches. That means individuals like you enroll in our batches during the weekends and learn through various different technologies. We are at present coming up with these batches of Azure Data Engineer, Azure Developer Associate, and DevOps Engineer. So these are all Microsoft courses. We are Microsoft Silver Learning Partner. So we hand over you the Microsoft official curriculum. We deliver the trainings. Our trainings are mostly case study oriented trainings. And you would have seen that we use drawing pads. We try to make things interactive. We draw and explain the stuff so that even though we are in a virtual environment, it's easier for the participants to grasp those things. So these are 3 of the upcoming trainings. We are also coming up with Google Cloud training as well in the month of September sometime. So stay tuned in case you wish to enroll in any of our training programs. Please try drop a mail or connect to us on this phone number. You can WhatsApp on this number or call on this number, and our sales team would be happily helping you with all the details about the courses. If you have any queries, if you want to drop us an email regarding any of the things, you know me, you know Shivam, you are connected to our LinkedIn Tech Scalable page. You can connect with any one of us and register for the training program, or if you just want to come for our webinars, you're still welcome for it. So that was all from my side today. Hopefully you people liked it. Let me quickly check the StreamYard link. What is giving 404 error? I'm not sure. Chandrasekhar.
So the quiz link is in the chat. If you open that in incognito mode, I hope it opens up. I just tried it.
Yeah, it certainly opens up in an incognito window because I too have tried it. So let's try doing that. Yep.
Mamta, how much time is there for the quiz? Do we have any time limit?
It's not like the time limit. We would be evaluating the stuffs tomorrow. Maybe they can take 2 hours. 12:30, I think we would close it. Whatever responses comes by 12:30, will that do? 2 hours? It's
Okay,
enough time, I would say. So we have just tried comparing Azure Arc with other services, and few basic Kubernetes questions also we have put in. Please use this opportunity to grab an exam voucher or a book of back publication so that you can learn more about different varied technologies. You have the sales email ID and the phone number in the chat in case you want to connect to us. You can certainly use that. Quiz link is on the chat. Let me just post it on the LinkedIn as well. Once again. I'm unable to post it on the chat. Shivam has posted on the chat. I'm not sure why you people are missing on it. Because of some reason, it has like scrolled up or something. It's opening in an incognito window, so it should open up. 𝐀𝐠𝐞𝐧𝐝𝐚, if you can just check the permissions of your quiz link which you have given. I know I'm calling out your name. If you're there, can you just respond us on our chat message? Mukesh is saying, can you answer my last question? What authentication method is being used to connect 𝐀𝐠𝐴 and 𝐺K with Azure Client? And what is the credentials stored? So we are using service identity, managed service identity that is being used. And my Azure Arc is you are asking about how your Azure Arc is getting connected, right? So Azure Arc is using that MSI to connect, and your agents are nothing but containers running in the same cluster. So they don't need any authentication after that. Once it is created, it is good to communicate with any container in that cluster. So they should be able to communicate to every other container and grab the details. Please share the link without the prefix. Okay. Anyone who is able to access the quiz link apart from we within the company, if someone can just confirm, that would at least confirm that yes, others are able to. Quiz results, we would be announcing, Hitesh, tomorrow in the morning, but quiz would be closing in 2 hours' time. After 12:30, we would just grab all the results and analyze that. Just make sure you give your correct name, correct email IDs, because we would be looking you in LinkedIn. We would be searching you with this. So make sure you give your correct name, location, and all, because sometimes the name is same. So we just go and search according to that. Okay, thanks, Kuntal. So people are able to access. Rama, if you can just refresh and try out a different browser, because others are able to access. It should not be an issue with the link. Shivam, anything if I have missed, if you'd like to cover, anything if I have forgotten to cover?
No, Mamta, thank you for the amazing session. It was very informative and amazing demo as well. And I'm pretty sure everybody loved it.
Thank you. Great. So people are submitting the quiz form as well. Someone was asking for the architectural diagram. Architectural diagrams, I've not created anything of my own. You can just Google them. You just say Azure Arc architecture, you would find it. But if you want me to put this, I can put that on a OneDrive and share the link on the event page tomorrow. I'll do that so that you have that handy. Yes, Rehan. The recording would be available in YouTube immediately as soon as we close it. Live session will get closed and recording would be available. It would be available on our LinkedIn event page, and you can go through our company page of LinkedIn as well. So from wherever you have registered, you can find all the details there itself, Mukesh. You would be able to find the details of the recording there itself. Nothing different. Just go to the LinkedIn page again. It would be available as a recorded video. You can go and play. What is the schedule for tomorrow's session? I fear we don't have any schedule for tomorrow's session. We don't have a webinar tomorrow. Rather, the webinars are on different dates. They are on 27th. Sorry. Yeah, 20th of July. The next upcoming webinar is 20th of July. If you were asking about that, Sudesh. Thank you so much. I think everyone has enjoyed the session and it was fruitful 2 hours for you people. So thanks a lot for logging in and motivating us as well to do much more sessions like this. Please join us on our LinkedIn page so that you can stay tuned to much more updations about what we are doing. We keep doing such webinars, which helps you learning new stuffs. These are the webinar series. You would get update about all these webinars on our LinkedIn page. So please make sure you register or you become a member of our LinkedIn page. Company's name is 𝐀𝐠𝐞𝐧𝐝𝐚. So go ahead and register yourself as a member for our LinkedIn page. I think we are done. We would be posting messages tomorrow with respect to the quiz winners. Stay tuned for it. We would have the winners announced on the LinkedIn event page and our page of 𝐀𝐠𝐶alable page as well. So Shivam, I think we are good to close the session.
Okay, sure. Thank you, Mamta. Thanks everyone for joining us.
Thank you. Stay
Thank you.
tuned, guys, for the updates and stay safe. Thank you. Thanks, Shivam.
Thank you,
Thanks,
everyone.
𝐀𝐠𝐶. Thanks, Gopal.
Thank you. Bye bye. Good night.
Bye, guys.